Captain Coder here, and we have a request from Kaze over on the Unity Tutorials subreddit asking how can we scale a score depending on the accuracy the player has when shooting at a target. So we have a target on the screen, we're trying to get as close as we can to the center, and the player is going to get a score that is greater when they're close to the center and a little bit less as they go out. Before we hop in, I want to remind you, you can catch me live on Twitch over at twitch.tv/thecaptaincoder. And if you want to ask your own questions, don't forget to join Captain Coder's Academy Discord. You can find links to those down in the description below. Let's go ahead and hop in. I have set up here a Unity 2022 2D project. You can do a 3D project. It should also work going back to Unity 2020. I don't think anything drastic has changed between 2020, 21, and 22 for what we're doing today. I have this target sprite here that I'm going to add this to the screen. And the idea is I'm going to use a mouse click. When I click on this, I want to detect how close I am to the center of this object. To get those mouse clicks on this particular game object, I'm going to add in a circle collider here, so a 2D circle collider. And so this will allow us to detect the mouse clicks in our script. Let's go ahead and create a script as well. I'm gonna call this my target controller. It's gonna detect the mouse clicks on it. Let's open up our target controller script here. And we're gonna modify that. So because we have a because we have a collider, we can write the method public void on mouse down. Mouse down is going to be added magically for it's a magic method that gets added on the collider there. We'll do a debug.log clicked, and let's just check whether or not this is getting detected properly first. So come on over here, let that build. We're gonna add the script to our target. I'm gonna click on the target, go into the inspector, add in our target controller. When I run this, ideally we can check if it worked. When I click on this, we should be able to get that clicked. When I click not on it, nothing happens. So I can get that click to fire multiple times here. It also works regardless of whether it's a trigger or a not trigger. So I'm gonna use a trigger. Ideally, we want things to be able to move into this. If it's not a trigger, other rigid bodies will bounce right off of it. So we're gonna go ahead and make it a trigger. The next thing I want to do is determine how close that mouse click was to the center. To do this, I first need the actual mouse position. So I can do input.mouse position. So this will get us the screen space position, and pull that out. Let's do a debug.log on that. So the screen position isn't quite what we want. We'll be able to detect where the mouse clicks. You'll notice that my target is currently positioned at -5.5 and 1.3-ish. If I run this, I want to get a number that's sort of similar to those. If I were to click in the center, it'd be exactly that value. But I'm actually going to get back the pixel position here. So 122, 247. That's how many pixels I am from the top and the left on the screen itself. So we need to translate this to the world space. We can do this using the main camera. If your game has multiple cameras, you can get access to that camera and do a translation based off of that camera. But we're going to do a world, screen to world point. We're going to pass in our screen position, and this will produce a vector for us that is relative to our world space. We'll do a vector 2 here, world space. And if you're in a 3D game, you'd want to do a vector 3 world space rather than a vector 2. So we have our world space here. I'm going to call it world position, actually. World position. And now if we do a debug.log on our world position and take a look at that, we will hopefully see if everything went according to plan. As I get closer to the center, we're closer and closer to this position here, -5.5 and 1.3. And then if we were to move our target around the screen, it will detect based on where it is. Let's give that a shot here. Once Unity finishes compiling, go ahead and run this. And when I click here, when I'm close to the center, I get pretty close, negative 5.4, 1.3. As I move further away, it is getting further from that point. If I were to reposition this target, it's based on where this target is. So it's actually the world space, not the screen coordinates based on the pixels. Fabulous. The next thing we want to do is we want to detect, okay, how far am I from the distance? Sorry, how far am I from the center of this? What is the distance I am from the center? To do this, we want to calculate the distance. So we have a magic method here. This is a helper method called distance. Vector2.distance is a static helper method that accepts two vectors. So we're going to do our world position vector, and then the position of our target. Since the target controller is attached to it, we can do transform.position. And this is going to get us our distance from center. All right, so we have a float here that is how far away we are from the center. If we're directly in the center, it'll be 0. If we're far away from the center, it'll be, if we're on the edge of our collider, it's going to actually be the radius of that. So let's take a look here, debug.log, distance from center. We'll look at that real quick. Let it compile again, and then we'll run it. And in a moment here, if everything went well, sure enough, when we click towards the center, it's pretty close to 0.1. So we get further away, it increases until we're at the radius there of about 2.35. What we want to do is we want to scale this to be sort of, we want our max score if we're at the center, so that'd be a percentage of 100%, and it'd be 0% if we're at the edge here. So we can calculate the percentage of how close we are, our accuracy, in the following way. If we take our radius, which we have to calculate here, I'm going to create a variable up at the top. It's going to be a field private float radius. If you're using not a circle, you might have to do a different calculation. But since we have a circle, I can actually get the radius of our collider. And I'm going to do this in my awake method. So in awake, I'm going to go ahead and abstract that. I'm going to cache that value here. Get component, not abstract, but extract. I know we have a circle collider 2D here, and I can pull out the radius, and I'm going to save that radius in our radius field here. This member variable radius is now going to have the radius of our circle. So this is sort of the maximum distance we can be away from the center and still get points. In fact, if we're right on the radius, it'd be 0. And then we need to figure out how close we are. 1 would be as close as possible, that'd be 100%. 0 would be 0%. 0.5 would be 50%, that's halfway between. We can figure out that percentage in the following way. Percentage, we take our radius and we subtract our distance from center. Okay, so if we're at the center, this would be 0. So our radius would be the maximum value. And then if we divide that by the radius, we would get 1. So radius divided by radius would be 1. 0, so if we're as far away as possible, it would be our radius value. So radius minus radius would be 0. Divided by radius would also be 0. If we're halfway between, we'd get radius at the halfway point divided by the radius, we get 0.5. So this will give us the percentage, how close we are to the center. We might call this accuracy. I'm going to call it percentage here. And then let's create a variable, public float max score. So if we have directly in the center, this is the highest score we can get. I'll do here float score equals our percentage. So we're going to scale this up by our max score. Again, this is going to be a number between 1 and 0. If it's 1, we're going to have max score. If it's 0.5, we'll have 50% of the max score. And if it's 0, we'll have 0 of the score. And finally, let's go ahead and debug.log the score here. And take a look at that. And if all went well, when I click towards the center here, well, I'm getting 0 because I haven't set my max score. Let's set that to 10. As I'm towards the center here, I have 9.6. If I was directly in the center, I'd be getting 10. It's really hard to do that. As I get further out, I get closer to 0. If I'm right on the edge, I'm almost at 0. We can make it scale a little bit differently. So as you move closer to the center, it's going to increase a lot towards the center and decrease a lot at the end, but maybe we don't want it to ever be exactly 0, and maybe when we get sort of within 10%, we want it to be the max score. We're gonna do this using an animation curve. Let me make sure my max score is saved at 10 here. I'm gonna use an animation curve. So public animation curve, score. I'm gonna call this our score scale. And so it's gonna scale our score for us. Given that percentage, it's gonna tell us sort of how close we are to the center and how it should scale it. If you haven't used animation curve, don't worry, we can use it for non-animations. We're not actually animating anything. It just lets us do this cool thing in the inspector here where we can adjust this curve so we have a score scale. I click on this, I get this nice curve editor. I can say, okay, well, I want my curve to look like this. Rather than going straight at an even from 0 to 1, we can say, okay, well, I actually want you to scale up in a more interesting way. I like this one kind of bit. It goes up really, really fast and it slows down towards the top. I'm gonna add in a key here. I'm gonna say when we're at 90%, so that would be time. Oops, here, edit key. When we're at 90%, I wanna be at a value of 1. So 100, this is the same as being at 100%. So at 90%, if you're within 90% accuracy, get the max score. And then down here, I'm actually gonna make it so that if you have times 0, we're gonna have 10% of the max score. So the lowest score we can have in this case would be 10% of 10 would be 1. As long as you hit the target, you can get 1 point, go up to 10. Notice this curve goes a little bit, if we zoomed in, it goes a little bit above 1 here. We can flatten that out a little bit more if we come up to this key here. We edit, did I move that key a little bit? I didn't. We can select clamped auto and it's gonna flatten it out across the top here. So now we have this curve that says the score is going to scale in this fashion. It scales up pretty fast and then slows down as we get to the top, and then it clamps at 10, 100% that is. Now using our score scale, we can apply this here. We take our percentage. This is our sort of raw percentage. And I'm going to do our accuracy now. I have a variable called accuracy. I'm gonna take our score scale and we're gonna evaluate our percentage. So this is gonna say, take that percentage and find where it is on this curve and give us back that new value. And now our score, rather than multiplying by the percentage, we're gonna multiply it by our accuracy to get our score. Let's check it out this time. And when we run it, if all went well, we should see sort of it a little bit easier to get 10, maybe not super easy. So I get 10 as long as I'm pretty close to the center. I don't have to be directly at the center anymore. As I move out, it goes down and then you sort of, it scales up pretty fast. Notice I get in here, we have 5 points, we have 8 points, and as we get towards the center, we get 10 points. So using an animation curve, doesn't have to be for animations, get a nice little curve in there for your score to scale up or down. All right, I hope you found this helpful. How are you gonna use this? Are you gonna use animation curve for something else? Are you gonna make it into a 3D target game? I wanna know. And as always, keep coding, keep growing, be the best you can be, and you are welcome back anytime. Bye-bye.